Hi everyone. So in our previous presentation, we covered decision trees. So what are decision tree? So it is a tree. We are going to form a tree-like structure. Basically, you are going to use decision trees in order to make a decision. It will usually be a binary decision. So it can be somewhat like interaction type of decision. For that, I gave an example where the patient is going to interact with the doctor. So based upon that, he will keep on, the patient will keep telling the symptoms. So the doctor will keep ruling out the diseases which are not associated with the symptoms. And finally, will come to a conclusion. So that means you will construct a tree. So at each branch of that particular construction, you are going to take different branch. So you're going to lay out one branch and you're going to take one different branch. So the probability of coming to a conclusion will be more since you're taking one specific branch, one specific branch of that particular tree. So that is decision tree. And also we solved a problem in decision tree. So just go through that particular problem. It will be very much important from your exam point of view. That is given the weather conditions, whether it is allowed to play or not. The play would be yes or no. So there was a lookup table. So using that lookup table, we constructed the decision tree. First, we need to determine root node, then the left and right sub-tree. Then there was a test sample. So we applied the test sample on the decision tree constructed. That gave us the result. That is play is yes. So now we are going to start with one more machine learning algorithm, which is called as regression. So basically, your regression, it is a statistical techniques. So it is mainly related to mathematical models. So what do you mean by statistical technique means there will be plenty of variables in any problem. So you're going to find the relationship between the dependent variable and several independent variable. There will be plenty of independent variable. So you are going to find the value of the dependent variable based on that independent variable. For that, first you will identify the relationship between those dependent and independent variable. That will be in the form of an equation. So once you get the values of independent variables, then you can apply those values to the equation to obtain the value of dependent variable. Let us see how we can do that. So as you can see, it is a well-known statistical technique to model the relationship between several independent variable and one dependent variable. The object is to find the best fitting curve for a dependent variable in a multidimensional space. That means your dependent variable, the equation you are going to form, which shows the relationship between dependent and independent variable, that should be as much best as possible. That is called as best fitting curve. Usually, you will get the best fitting curve when it is a linear line. So it should be a linear line. That means if the independent variable is changing, accordingly, the dependent variable should change. That is called as linear line. This is usually measured with a coefficient called as coefficient of correlation. This particular coefficient of correlation is used to measure the relationship between your independent variables and dependent variable. So that coefficient is calculated by the square root of variance. So how different are independent and dependent variable? So that is how you are going to calculate the coefficient of correlation. That you are going to see in detail in the next slide. So basically, in regression, you are going to form a you are going to use statistical method to form a equation. That equation contains dependent variable and independent variable. So you are going to find the value of your dependent variable based upon the values of independent variable. So that is actually we are doing. So we are forming a relationship between dependent and independent variable. Some of the steps we can follow for regression are as follows. So steps are the what all I just explained. You should list which are all the variables which are available. It can be independent variables and also it can be dependent. Only there will be only one dependent variable, but there can be plenty of independent variables. Establish a dependent variable of interest. So which is a dependent variable that you need to make a note of it. And then you need to find if there is any relationships between the independent and dependent variable. The last point, you need to predict the value of dependent variable using all other independent variables. There will be plenty of independent variable. Using those independent variables, you will be predicting the value of dependent variable. So this is how you are going to establish, how you are going to measure the relationship between dependent and independent variable. So using a method called as correlation. So what do you mean by correlation? statistical relationship are about which elements of data hang together and which one hangs separately. So if you are finding statistical relationship between any two variables, then that means which variables are found together. That I can say if one variable is increasing, whether other variable is also increasing. That you are going to see here. So the first and foremost strength of a relationship is correlation. The strength of correlation is a quantitative measure that is between 0 and 1. So 0 and 1 means if the correlation value is 1, they are perfectly correlated. If the correlation value is 0, then they are not at all correlated. If the correlation value is 0.5, then they are correlated by 50%. So a correlation value of 1 indicates perfect relationship, 0 indicates there are no relationship between the variable. The relationship can be positive or it can be inverse relationship. That we are going to see with the help of correlation coefficient. So how we are going to find correlation coefficient? It is the square root of correlation. So what this will do, Andre, this is a value which ranges from -1 to +1, where your correlation ranges from 0 to 1, but coefficient of correlation ranges from -1 to +1. So how we are going to calculate? And value of 0 indicates there is no relationship. A value of 1 indicates positive relationship. What do you mean by positive relationship? If independent variable are moving in one direction, then the dependent variables will also be moving in the same direction. That is positive correlationship. Next is -1. If the coefficient of correlationship is -1, then it is negative relationship. What do you mean by negative? If the independent variable is moving in one direction, then the dependent variable will also be moving by same weightage, but it will be in the negative direction, opposite direction. It won't move in the same direction as that of your independent variable. So your coefficient of correlation ranges from -1 to +1. 1 means positive correlationship, -1 means negative correlationship, and 0 means no correlationship. So given two numerical variables, the coefficient of correlationship is a mathematically computed. So this is the formula where you can compute the coefficient of correlationship. So there are two variables x and y. So for those two variables, this is how you can calculate the coefficient of correlationship. Let us see this coefficient of correlationship with the help of these 6 diagrams. As you can see, this is a linearly correlated. Both these variables are positively correlated. What do you mean by positively correlated? As x is increasing, y will also keep on increasing in the positive direction. It is increasing in the positive direction. So this x and y variables can be called as positively correlated. They are positively correlated. So this is called as negatively correlated. Whenever you are finding a linear curve, then it is perfect correlationship. So this is negatively correlated. Why? Whenever the value of x variable is increasing, the value of y variable is decreasing. That's why it is negatively correlated. This is curvilinear. Curvilinear in the sense there is no perfect relationship, but there is some relationship. When x is increasing, y is decreasing, but not in a linear fashion, in some other fashion. So this is also curvilinear. When x is increasing, y is increasing, but not in a linear fashion, in some other fashion. So when you find a linear correlationship, you can form a linear equation. But if it is somewhat curvilinear, then you need to use quadratic equation, higher order polynomial. So these two cases represents no relationship at all. As you can see, there are in random place. So if x is increasing, y is somewhere. If x is increasing, y is somewhere. So these are some of the relationship charts you can look. That is what has been explained in all this below paragraph. So for what we covered what is regression. It is nothing but a statistical technique used to find the relationship between independent and dependent variable. You are going to form a mathematical equation. That equation contains dependent and independent variable. If you provide values for the independent variable, then it will give me the value for dependent variable. These are the steps for a regression. Then we saw what is correlation and what is coefficient of correlation. The range is -1 to +1. This is some of the relationship we can find. Perfectly positive, perfectly negative, curvilinear, negatively curvilinear, positively curvilinear, no relationship, no relationship. So let us look at some regression exercise to get clear picture on how your regression will work. So the regression model, as I had already explained, it is a linear equation. As you can see, this is my linear equation. So where there could be many predictor variables. However, there can be only one independent variable, the dependent variable. So this is the dependent variable. On the RHS side, you can have many independent variables, but here we are having only one independent variable. So this beta 1 and beta 2 are constants, and the quotient for the x variable, and epsilon is the random error variable. This is for any variance, you will include one random value. So these are the independent variables and this is the dependent variable. So based on the value you get in independent variable side, you are going to calculate the dependent variable. So this is a simple data set. This data set contains house price and size of the house. So here your house price is a dependent variable, your size is a independent variable. That means you are going to calculate the house price based on the size of the house. So if the size increases and if the house price increases, then it can be positively correlated. So whether that positive correlationship is linear or not, what do you mean by linear? So it should be in a linear fashion. So it should not be in a curvilinear fashion. That we are going to see here. So the two dimensions, this is the plot for the data set that has been provided in the upper diagram. So as you can see in the data set, this is the house size and this is the house price. So there is a linear relationship. So there is a positive relationship, but it is not linear. Linear means it should be a complete straight line like this, but it is not linear. As you can see, visually one can see a positive relationship between house price and size. However, the relationship is not perfect. That means it is not completely linear. Running a regression model between the two variables is following output. So when you run, there is a statistical model called as regression model, inbuilt machine learning algorithm. So when you run the regression model, you will get these values. So R and R square. So what this indicates means coefficient of correlation. Your R indicates that means they are 89% correlated. So they are not 100% correlated. They are 89% correlated. This R square is the variance. What do you mean by variance means? So if size changes, how far house price will change? That is variance. So that variance is 79%. So it is also not perfectly correlated. In order to get a perfectly correlated instance, you need to get R should be 1, R should become 1, your coefficient of correlation should be 1, and also your variance should be 1. That is called as perfectly correlated. So we will take one test sample. This is the test sample. As you can see, this will be the final equation. So whenever size is provided, you can directly apply size here and find the house price, because this is the equation you have got from, as you can see, this is interrupt and say this you need to remember, because these are the values which you get when you run the regression model. So when size is given, you are calculating the house price. This equation you formed mainly from the regression model. The regression model helped you to form this particular equation. So this equation explains only 79% of the variance. As I had explained, the correlationship is 89%, whereas the variance is 79%. But this is not perfectly correlated. So what we are going to do, we are going to add one more independent variable. So more the number of independent variable you are going to add to the regression model, better will be the coefficient of correlation you will get. So what we are doing is, so we are adding one more independent variable, that is number of rooms. So now we are going to decide the value of dependent variable based on these two independent variable, size of the house and number of rooms. So these both independent variables will contribute to calculation of house price. So as you can see now, when you include both the things, now the coefficient of correlation you are getting is 98% and the variance is 96%. There is a clearly an increase in the coefficient of correlation and variance. That means if number of rooms and house size changes, then there will be 98% correct according change to the in the house price. So if there is if the house price, sorry, if the size and number of rooms is getting varied, then your house price will also get varied by 96%. So based on extra variable, this will be the final equation that you got. So here, if any size of the house is given and number of rooms is given, if you input those values in this particular equation, you will be getting the house price. As you can see, this is an example where size of the house and number of rooms are given. So when you input those values, you will be getting the final house price. So basically in regression, you are going to find the value of the dependent variable based on many independent variable. There will be many independent variable. So based on those values, you'll be finding the value of dependent variable. So let us see one non-linear regression exercise. So far, the exercise we covered is linear. That means the line we were getting with respect to the independent variable and dependent variable, it was a linear line. So in this case, it is not linear, but when we include one extra variable number of rooms, it will be a linear line because the coefficient of relation is 98%, which is close to 100%. So what if we don't get linear line? As you can see, this is not a linear line. This is not a linear line. So plots, as you can see the plots, this is a curvilinear. This is how we should plot. It is a curvilinear line. So in this regression exercise, what we are doing, given temperature, so you'll be calculating kilowatt. What usually happens if the system or any machine is getting hot, then the temperature of that system or machine increases. Then the consumption of power will also be more. So if there will be a correlation between temperature and kilowatt. So for that, we are going to plot a regression model. So this is the regression model. So this is what we plotted for the first time. This is the temperature on x-axis and kilowatts on y-axis. As you can see, you are not getting a linear line. You are getting a curvilinear curvilinear line. So how we can make it linear? Because this is of no use. So in order to create an equation, you need to use quadratic equation. That will be quite complex. So what we did is, instead of taking temperature, we took temperature square. So when you take temperature square, as you can see, it is visually clear that the first line does not fill the relationship between temperature and kilowatts follows a curvilinear model. The regression model confirms, so coefficient of correlation is 0.77 and variance is 60%, only 60% when. Now what we are going to do, instead of using a temperature, we are going to use temperature square. When you use temperature square, then this is the plot. This is a linear line. So now the coefficient of correlation is 99%, as you can see here, and the variance is 98%. That means if temperature increases, then accordingly the kilowatts will increase by 99%. And if there is any change in temperature, then accordingly the change will happen in kilowatts by 98%. So this is the final equation that you will get, but now it is a quadratic equation. It is no more a linear equation. Now it is a quadratic equation. So if you apply all the values given, if any temperature value is given, if you apply here, then you will be going to find the kilowatts. So this is the non-linear regression exercise. So for what we covered what is regression, what are all the four main steps of regression that we covered. Then we covered correlation and relationship. Later on we covered some visual relationship of different relationship available between independent and dependent variable. Later on we covered two regression exercise. The first regression exercise is quadratic, so simple linear line, but it was not completely linear. So we included one more independent variable, number of rooms. Then there was a non-linear regression exercise. We made it linear by making temperature as temperature square. It became a linear equation. So now we are going to see one more type of regression called as logistic regression. So in order to understand logistic regression, first see these values. All these values are continuous values. All these values are continuous values. So you are going to obtain a continuous value here. The result will also be a continuous value. When I apply temperature to this particular equation, the energy consumption in kilowatts, that will also be a continuous value. So that means it is a number, numerical number. But if I want only a classification, either an S or a no, then the option would be to use logistic regression. So logistic regression is basically used when you want the result to be either yes or no, either 1 or 0. At that time, you are going to use logistic regression. So how logistic regression will happen in the sense? So as you can see, regression model traditionally work with continuous numeric values, just as we saw in the previous regression exercises. Whereas your logistic regression model work with binary variables, dependent variable that are categorical values. That means loan approved or not. So it is a binary value, loan approved or not, 1 or 0, yes or no. So you need to measure the relationship between that dependent variable and more independent variable. So for that, Let us take an example where there is a patient who is giving the symptoms. So there you are going to check whether a particular disease is found or not. So all those symptoms will come under independent variable. Disease found or not, that will be a dependent variable, categorical dependent variable. Categorical means binary value, either 0 or 1. So in order to plot such a regression model, what we are going to do, this is a probability. So that means one time you can get disease found, other time you can get disease not found. So based on that probability value of dependent variable you are getting, you are going to apply logarithmic function. So as you can see, this is the logarithmic function you applied on those positive values. So it can be 1, 0 or 0.1. If it is 1, then I can say those symptoms are correctly giving this is found or not. If it is 0.5, there is 50% probability disease might be found or may not be found. If it is 0, the probability or the answer given is completely wrong. You cannot consider that particular result. So thus you are going to use logarithmic value or logistic value of that dependent variable. So as you can see, logistic regression takes the natural algorithm of the probability of the dependent variable. So thus the logit transformation, whatever the logarithmic value you will be getting, that will be used as a dependent variable. So as you can see, the net effect is that although the dependent variable is binomial, the logit is a continuous function, 0, 0.5 and 1. Thus it is a continuous function. So this is how we are going to deal with the dependent variable where it has only two values, either yes or no, that is categorical values, with the help of logarithm. So the last topic in this regression model is advantages and disadvantages. So it offers many advantages then compared to disadvantages. Let us see what are all the advantages with respect to regression model. It is very much easier to understand because it is simply based on statistical principles. So there are simple statistical principles, that is correlation and variance. So using that you can understand regression easily. You are using only simple algebraic equation, either a linear equation, at most a quadratic equation. And also you are going to measure the strength of that particular equation with the help of correlation coefficient. So that will be easy to find the accuracy of regression model. So it gives correct accuracy. If the coefficient of correlation is 1, then that means positively correlated, -1 negatively correlated. That gives the perfect relationship. So your regression model can beat the predictive power of any other model techniques. So you can include all the variables. If there are many independent variables you are including, then you can get better results. The dependent variable, the coefficient of correlation will be close to 1. So you can easily plot regression equation and regression data in MS Excel. So it is quite easier to use regression model. Some of the disadvantages is if the data quality, the dependent variable data and the independent variable data you are using and the dependent variable data you are using, if there is some data quality issues, then regression model is not the perfect model. Correlative problem, that means sometimes what happens there, if there are many independent variable, those independent variable itself will have some correlationship. So when those independent variable itself has some correlationship, they will eat into the power of predicting dependent variable. That is what has been mentioned here. If the independent variables have strong correlation among themselves, then they will eat into each other predictive power and the regression coefficient will lose the ruggedness. So this is what the second disadvantage. The third one is if there are large number of variables that you are going to include, then it is unreliable actually. What do you mean by unreliable? In the sense there is some uh, constant, or I can say there is some threshold. Behind that threshold, you should not include many independent variables. So that threshold should be decided. If you are including more, then it is not suitable. The equation becomes very complex. It will be higher order polynomial equations. So if there is non-linearity, as we saw in that temperature and kilowatt, that needs to be converted. That is a disadvantage. So basically, the regression model work with only numerical data, continuous data. For categorical data, that means with binary values, your regression model doesn't work that much good. These are some of the disadvantages. So in this presentation, we covered what is regression, what are all the 4 steps involved in regression as we go up. We covered what is regression, what are the key four steps of regression. Then we saw correlation and relationship. The strength of a correlation ranges between 0 to 1, whereas coefficient of correlation ranges between -1 to +1. Then we saw some of the diagrams to explain all those relationships. Then we saw regression exercise. One is a linear equation regression exercise. So in order to increase the coefficient of correlation value, we included one more variable called as number of rooms. Then there is nonlinear, that is temperature and kilowatt. So in order to make it linear, we made the independent variable to become temperature square. Then we saw what is logistic regression. So if you want to deal with categorical data, that is binary data, then logistic regression is the solution. Lastly, we saw advantages and disadvantages of regression. So just go through the entire presentation. So in this module, there will be 2 or 3 important questions. I will make sure I'll be giving those questions in the assignment. So watch the entire presentation. So watch this before after watching your decision tree presentation. If you get any doubts with respect to the presentation of regression or decision tree, you can ping me the doubts. Thank you.